Okay, man, what we have here is the write-up to yesterday's problem. I'll let you guys pause the video and take a look at it, and if you have any questions, just go on and submit them in the questions discussion folder. Another common situation that leads to a two-way table is when a single random sample of individuals is chosen from a single population and then classified based on two categorical variables. In that case, our goal is to analyze the relationship between the variables. Our null hypothesis is that there is no association between the two categorical variables in the population of interest, and the alternative is that there is an association. This is what we call the chi-squared test for independence. If you take a look at the conditions for performing a chi-squared test for independence, they're the same. There is nothing different here about our conditions. And if you look, there is no association between the two categorical variables for the null, and there is an association. We're still going to calculate the chi-squared as observed minus expected quantity squared divided by expected. We sum all those up. You have to find the expected count for each category. So again, that's row total times column total divided by table total. And the degrees of freedom is the number of rows minus 1 times the number of columns minus 1. And the p-value will be the area to the right of chi-squared under the corresponding chi-squared density curve. Is there a relationship between gender and relative finger length? In Chapter 5, we looked at a sample of 452 U.S. high school students who completed a survey. The two-way table shows the gender of each student and which finger was longer on their left hand. Do the data provide convincing evidence of an association between gender and relative finger length for U.S. high school students who filled out the Census at School survey? So the null hypothesis here is going to be there is an association between gender and finger length. And the alternative is there is not an association between gender and finger length. Okay, we're going to test at 5% significance. My assumptions, we said that we have a simple random sample was taken. They said they took 452 U.S. high school students selected. All right, all expected counts are at least 5, so normality has been taken care of, and there are more than 4,520 teenagers in this. So the name of this test is a chi-square test for independence. Okay, to calculate my chi-squared value, chi-squared is equal to, and it is 78 minus 57.69 quantity squared over 57.69 plus ... 43 minus 50.44 quantity squared over 50.44. When we add all those up, you get a chi-squared value of 29.02. So, to obtain my p-value, the probability that chi-squared is greater than 29.02 is equal to chi squared CDF. And we're going to say lower is 29.02. The upper is 1 times 10 to the 99th. And the degrees of freedom is 2. Rows minus 1, column minus 1. So that becomes about 0. So since P is less than alpha, 0 is less than 0.05, we will reject the null, and there is convincing evidence there is not an association between gender and finger length. And that's for high school, U.S. high school students who completed the survey. Just like yesterday, I'd like for you guys to try this example on your own, and that will be your homework tonight, so please submit this problem to the homework page. Remember, you have until Monday, and you have a reading quiz to do. So make sure you get this example turned in on the homework. Thank you. So, I think at this time, I should just talk to you about the chi-square test for homogeneity and independence. They seem to be the same, but they answer different questions. The chi-square test for homogeneity tests whether the distribution of a single categorical variable is the same for several different populations or treatments. So, do cell phone only users differ from landline users in political party affiliation? The chi-square test for independence tests to see if two categorical variables are associated in some single population. Is there an association between heart disease and anger levels in people with normal blood pressure? The reality is we use the same conditions and same methods to determine if we have convincing evidence. If you can't remember the name of the specific test, it's okay to simply say that you're using a chi-squared test. How is this related to the chi-squared goodness of fit test we looked at last time? The chi-squared goodness of fit test is a single categorical distribution follow a specified distribution. So online social networking, an article in the Daily Arizona Daily Star, April 9th of 2009, included the following table. Suppose that you decide to analyze these data using chi-square test. However, without any additional information about how the data were collected, it isn't possible to know which chi-square test is appropriate. Explain how you know that a test for goodness of fit is not appropriate. B, describe how these data could have been collected so that homogeneity is appropriate. And describe how these data could have been collected so that a test for independence is appropriate. So, for the answer or solution to part A, there are either two variables or two or more populations. A test for goodness of fit is not appropriate. Tests for goodness of fit are appropriate only when analyzing the distribution of one variable in one population. To test for homogeneity or to collect the data, we would need to take 6 independent random samples, one from each age category, and then ask every person whether or not they use online social networks. Or we could take 2 independent random samples, one of online social network users and one of people who do not use online social networks, and ask every member of each sample how old they are. Finally, for part C, to test for independence, we would take 1 random sample from the population and ask every member about their age and whether or not they use online social network. This seems like the most reasonable method for collecting the data, so a test of independence is probably the best choice. But we can't know for sure unless we know how the data were collected. That wraps up part 2 notes for 11.2. So we are finished. We're ahead of the game. So I appreciate your all's attention, and I wish you guys a great day. I hope you have a happy Easter, and spend the time with your family members. Enjoy this holiday season, men, and I will talk to you on Monday.